Hey guys, welcome back to Tech Insights with Dylan White. Hopefully you guys are enjoying your week. It's Friday. I think we're all ready for everything to kind of wind down and hop in the weekend. But of course we're not, because we're on day 6 of the 30-day journey to your SC-900, start your cybersecurity career. We're going to go over, again, starting into the actual SC-900 course, right? We're on day 2 of it. Yesterday we went through an overview of what will be on the course and how we should pass it and some things that we're going to go through along the way. However, I'd be negligent not to take about a minute away from our intro here, just to talk about what's happening in the world of cyber today. And I'm going to have a full video dropped on it and just my thoughts. But what I think we've learned from this gigantic global outage, right, between Microsoft and CrowdStrike today is how interconnected, right? Of course, we all want defense in depth. That's what we all want. But if we look at this from an actual IT and infrastructure and capabilities, we could see this coming, right? There's been more of a reliance on auto updates, auto patching, and as fast as possible, right? To a point to where it's almost negligent, right? Of these systems, right? Like we've gone away from update rings to just mass updates. Um, and as we can see in today's society, if we do this and do these kinds of systems on a mass update rollouts, it's bound to happen that some providers are going to make a mistake somewhere. I think what hurts, right, as a community is we blame one vendor or the other. Incidents happen, right? Accidents are happening. It's bound to happen. But as an organization, right, to reduce risk, I think it is negligent now to not say, hey, we need to have update rings to then stop this, right? Especially when it's such a critical vendor that touches every single system in your environment, right? Whether that's Windows, whether that's CrowdStrike, whether that's your VPN software, whatever it is, these kind of things happen. We saw it with SolarWinds 5 years ago. Um, these things just happen. It's incredibly unfortunate, but we have to have internal risk procedures to mitigate this, especially around updates, right? Updates, 0 days, they all happen. We know they happen in the industry. So that's my spiel. I'm going to drop a video on it and with my true thoughts. Once again, these are my thoughts on how it can be mitigated. Once again, these are my thoughts on how why I think stuff like this happens. Once again, it wasn't a cyber attack. It was literally an infrastructure issue with a patch. And unfortunate, it just happened, right? Unfortunately, CrowdStrike is one of the best vendors in the world, and they have infiltrated what maybe let's call it greater 80% of the largest organizations of the world. So things that happen to them just tend to happen then to everybody, right? Just like when something happens to Microsoft, SolarWinds had the same thing, right? We saw it with the file server, right? Move it. It's just unfortunate. So I'll drop a video on that. But guys, all I'll say is your organization's using CrowdStrike. I wish you the best today because it's going to be a long one. But let's get into it. We're going to dive into day 2 of the 25 days left for the SC-900. And today we're going to dive through the security concepts of from Microsoft. Let's get it. All right, guys, let's dive into it, right? So we're going to go through the security and compliance concepts from Microsoft, and we're just going to go through it. So the way we're going to go over these next 25 days is we're going to do some modules. We're going to do some mind maps based off the modules. We dive into different pieces of concepts and kind of take it one step down, and then ones especially that I think are very important to know. Otherwise, we're just going to go through module by module, and we're going to dive in. Then we're going to break it up in between with either an Ask Me Anything. We're going to talk about roles, where you can find how to get jobs in these more experience. So let's get it. All right. So in this module, the objectives are pretty straightforward, right? Describe the shared responsibility model and defense in depth. We're going to also describe zero trust. We're going to describe security concepts of encryption and hashing. And we're going to just describe some basic compliance concepts. So we've already covered bits in for the Microsoft Security 101. We just talked about zero trust, talked about shared responsibility, defense in depth. We have not yet talked about encryption and hashing. We covered some bits of compliance. So let's see where the overlap is. But I'm super excited. All right, so let's get to it. We're going to skip the introduction on most of these. So what is a shared responsibility model, right? So organizations running only on-prem software hardware, right? The organization, 100% responsible for implementing security and compliance, right? With cloud-based services, the responsibility is shared between customer or the organization and the cloud provider, right? The shared responsibility model identifies which security tasks are handled by the cloud provider in which security tasks are handled by the organization, you, the customer, right? They vary depending on where the workload is hosted, right? So SaaS, which is software as a service, PaaS, platform as a service, infrastructure as a service, or on-prem data center, right? So when we walk through this, you guys should be familiar. If you went through the Security 101 with me, you guys have seen this exact diagram. There's a saying in organization IT as you move up, right? Maybe if you're at the very help desk level, you might not have heard this before, but maybe your bosses have told you, right? There is a methodology and a model going around by a lot of organizations to shift the security responsibility left, right? And that goes hand in hand with this model, right? Instead of having it on premises, we want to shift left, right? We're taking that responsibility, say, hey, data center, I want you to be responsible for everything else. Just take the servers, right? Or the applications. In PaaS, right? Platform as a service. You host everything, including that SQL. I just want to host the DB, right? I just want to be responsible for that. SaaS, right? I don't want to be responsible for anything besides the users and any of the data, right? That's it. So as you can see, a lot of what we're doing, the model, right, is all about risk and risk mitigation. Okay, that's the shared responsibility model in a nutshell. If you look at it, right, you can see everything from physical security to encrypting sensitive data for on-prem. Cloud services, right? IaaS requires most management by the cloud customer, right? With IaaS, right, we're using the cloud computing infrastructure, right? We're using their VMs or hosts, right? And we're not responsible for the physical components, right, or the networking there. However, we are responsible for the software components that are on that infrastructure, right? PaaS, very similar kind of concept to IaaS, but in PaaS, we're responsible for deploying the software, right? And SaaS, as all of us know, it's like, think about that as like Microsoft 365, think about that as Salesforce, think about that as NetSuite, QuickBooks Online, blah, blah, blah. Those are all SaaS providers. All we're using is their infrastructure, their applications, and we're just putting users and data in, right? So very, very simple. So let's get to the next one. Wow. Let's get to defense in depth. Okay. So what is defense in depth, right? It's a layered approach to security, right? Rather than relying on a single perimeter, right? Defense in depth strategy uses multiple layers, right? Each layer provides protection so that if breached, subsequent layer will prevent an attacker getting unauthorized access to your data, right? So you have a very good layout right here, example layers. Some organizations don't even need all this. I'm a diagram person. I hate just reading verbatim, so we're going to go through the diagram version of it. So you can see, right, there's physical security, there's identity and access, there's your actual bound perimeter, right? There's networking, there's compute, there's application, and then there's data, right? So you'll see some organizations will have a different security provider or different security methods and mechanisms for each one of these layers. And you'll see some organizations that have one vendor and covers everything, right? You've seen a lot, transition a lot over the last 3 or 4 years. But still today, you'll have some organizations that, to mitigate all risks as much as possible, they have a different vendor at every different level. But it does create much more of an architectural and you have to have a very big team to support all of those different layers. Right. Let's get into the CIA triad. We talked about this. This was the very first module in the Microsoft Security 101. But if you're not familiar with it, it's the bound basic of why we do security, right? It's to provide confidentiality of data, integrity of data, and availability of data. That's the CIA triad. Right? We talked about this. I'm not going to go into it in deep depth, right? The zero trust model. We talked about this too, guys. Like these basics, we've covered a good amount. That's why I wanted to show you the Security 101 first and dive into this because it will make way more sense, right? So zero trust assumes everything is open and untrusted, right? We assume breach at all times, right? Everything, even resources behind firewalls, the corporate network. The zero trust model operates on the principle of trust no one, verify everything. The attacker's ability to bypass conventional access controls and ending any illusion that traditional security strategies are sufficient by no longer trusting the integrity of the corporate network. Security is strengthened, right? There's a saying in there that goes around in the industry lately. It's been, if we treat everything as BYOD, we have more ability to accept the zero trust model, which is true. If you treat everything, because in a BYOD organization, it's a bring your own device organization. You are inherently saying, well, we're never going to trust you because that's your device at your time. So we're always going to do additional verification, right? Maybe we'll learn your home network and we won't MFA you after a certain amount of time based on, but if we see an anomaly where maybe at Starbucks that day, we are going to MFA you. Right? We're going to check your device again. We're going to do some extra layers of defense. So there's a video in there. We can talk through the principles, but again, I'm kind of a diagram guy, so we're going to talk about pillars, right? So you have verify explicitly, you have least privilege access, and assume breach at all times. Those are the 3 mandatory things of zero trust across 6 pillars, which is identities, devices, applications, data, infrastructure, and networks. Remember, guys, I talked about this a bit in the last video yesterday. There's 5 roles, which I think you have a lot of room for growth. The 5 of them are there. Networking from Microsoft is not, I don't think it's as easy of a jump from the SC-900 to get there, unless you come from a networking background. But I said, if you line your career up to one of these pillars, you'll go a long way. All right, encryption and hashing. This is one that we didn't talk about the last 4 or 5 days, but we're going to get into, and it's very important as you learn data, why encryption is very important. Right? One way to mitigate common cybersecurity threats is to encrypt sensitive data or valuable data. Right? Data doesn't have to be sensitive to be valuable. Everybody's data is a little different. Your organization treats data differently. Right? Encryption is the process of making data unreadable and unusable to unauthorized viewers. Right? To use or read encrypted data, right, it must be decrypted, which requires the use of a secret key. Right? There are 2 levels of encryption: symmetric and asymmetric. Symmetric encryption uses the same key to encrypt and decrypt the data. Asymmetric encryption uses a public key and a private key pair. Either key can encrypt the data, but the key used to encrypt cannot be the one used to decrypt. That's asymmetric in a nutshell, right? And so if we look at these, right, let's read the one about HTTPS. Right? Asymmetric encryption used for things such as accessing HTTP sites, protocol and electronic data signing solutions, etc. So if we look again, there's a diagram person. I learned visually. Symmetric encryption, you can see, right? It's unlocked. Put the shared key in, lock it. Shared key opens it back up. Asymmetric key, you have a public key, right? Unlock it. Put the public key in, locks. Private key from the host, the receiver, unlocks it again. Right? Encrypting data at rest, super important, right? Data at rest is the data that's stored on a physical data. It's my phone, right? It needs to be secured at all times. It's just a server, same thing, right? Maybe stored on a deep database or on a storage account, but regardless, where it stores encryption, data at rest ensures the data is unreadable without the keys and access and secrets needed, right? Encryption for data transit, right? From one location to another. So if you're transferring, a file from a Gmail to an Outlook, blah, blah, blah. It can be done by encrypting the data at the application layer before sending it over a network. HTTPS is an example of encryption in transit. Data in use, right, involves securing data in non-persistent storage, such as RAM or CPU caches that can be achieved through technology to create an enclave. Think of this as secure lockbox that protects the data and keeps data encrypted while the CPU processes the data. There's lots of different ways we're going to talk about encryption for data in use, and it'll be in probably in Microsoft solutions, if I'm not mistaken. Don't try to dive down that rabbit hole too soon. Hashing uses an algorithm to convert text to a unique fixed length value called a hash. Each time the same text is hashed using the same algorithm, the same hash value is produced. The hash can then be used as a unique identifier to the data. Right? Hashing is different to encryption in that it doesn't use keys, and that the hash value isn't subsequently decrypted back to the original. Hashing is often used for passwords. When the user enters the password, the same algorithm that created the stored hash creates a hash of the entered password. This is compared, right, to the stored hash version of the password. If they match, the user entered the password correctly. It's more secure, of course, than plain text. But hashing algorithms are also known to hackers, right? They're deterministic, right? They're algorithms. Hashing is not the most secure in the world anymore. For every match hash, they know the actual password. To mitigate the risk, passwords are often salted, right? Adding a fixed length random value to input of hash functions. So usually, right, most security tools and most password tools and just most user account tools, right, salt all their stuff. Right? They use a random salting, and you can see, right, the original text, hashed it, and now it's a hash. Straightforward, not at all. Hashing and encrypting is probably some of the most difficult things to learn in security. All right, let's dive into some concepts. And then I think there's a little quiz at the end. We'll crank that out. Okay. All right. So governance, risk, and compliance, also known as the industry and GRC. For those of you that are on social, right, like the Twitterverse. Sorry, Elon, I always call it Twitter. X. GRC got very big the last 4 or 5 months of, people wanting to get into it, people seeing it as a way to break into tech, right? And people just gotten really big in it. I would say that GRC is huge, right? Especially as we move from, I think, identity focus, right? So now most organizations are looking at their data in a different way. So here's a diagram of it, right? You have people, you have technology, you have processes. Right? So if you look at this, governance, right? Strategies, policies, monitoring, culture, right? You have risk, identify, analyze, and control. And then compliance, you have laws, regulation, controls, and activities, right? So as organizations establish GRC competency, right, or a culture around GRC, it's one of the last things. Some organizations either do it first or it's one of the last. Hopefully you do it first because it's harder, way harder to go backwards. They establish a framework that includes implementing specific policies, processes, and technologies, right? Structure approach for managing GRC helps organizations reduce risk, improve compliance effectiveness. An important prerequisite for establishing GRC competency is understanding the key terms, right? You got to understand it. Give me 2 seconds because I'm going to turn my Teams off. Boom. So governance, right? It's a system of rules, practices, and processes. I think by going through the diagram, it helps you understand a little bit more when we go into definitions, right? Example, organizations establish rules and processes that define who, what, where, and which users and applications can access corporate resources. Risk management process of identifying, assessing, and responding to threats or events that can impact the company or their customers' objectives, right? And examples include leaks of sensitive data, intellectual property theft, fraud, and insider trading. Now, compliance, that mostly refers to country, region, state, or federal laws, multinational regulations that your organization must follow, right? They usually regulate the type of data that must be protected, the processes that are required, and the penalties that are issued. I think of GDPR, I think of HIPAA, all these other things. Those are compliance policies, right? So you have data residency, data sovereignty, data privacy, all that good stuff. So remember, as we go through these, right, we're going to look at these module based. We're going to read through, we're going to go through the diagrams, but I really want you guys to dive into, right? This is definitely supposed to be a mutual thing. I already have the cert. I want you guys to understand it when you go take the test. Anyone that follows this pathway should be able to ace this exam. So let's hit the actual knowledge check together. Right? All right. So an organization that has deployed M365 to all employees considering the shared responsibility model, who is responsible for accounts and identities relating to these employees, right? Is it the org, the SaaS provider, or the shared responsibility between the org, right? Remember, we're looking, the question says, who is responsible for accounts and identities? It's going to be the organization, 100%, shared responsibility. But in that model, you, the organization, are responsible. All right, which of the following measures might an organization implement as part of the defense in depth? Looking at all of its servers in a single physical location, multi-factor authentication for all users, ensuring there's no segmentation of your corporate network. Well, I think if we're looking at defense in depth, we're going to go MFA. Right? MFA is another defense layer. All right, the human resources wants to ensure that stored employee data is connected. Which security mechanisms they use? So remember, HR wants to ensure that data stored data is encrypted, right? It's encryption at best because it's storage. Which of the following best describes the concept of data sovereignty, right? Regulations that govern the physical locations where data can be stored, how and when it can be transferred, processed, and accessed internationally. Data, particularly personal data, is subject to laws and regulations of country or region in which it's physically collected, held, or processed. Trust no one, verify everything. Definitely not the last one. So between 1 and 2, right? There are regulations that govern. There's a data, right? Particularly personal data. Data sovereignty. 9 times out of 10, you're talking about personal. Let's see. So I think we got them all right. All right. So we got through the basic concepts of security and compliance. Tomorrow we're going to dive into the identity concepts. I'm super excited because I got to retake my SC SC-900 and get that certification renewed. So once we finish that, we're going to jump into the renewal learning path. So thank you guys for sticking with me. If you guys like the content, if you guys like the little walkthrough of what happened with the quote-unquote Microsoft CrowdStrike global outage, let me know. Let me know your thoughts on it, thoughts on update policies, update rooms. Love to hear it. Thanks again, guys, for sticking with me. And please like and follow.